rolling a die, flipping a coin. If it's not a simple event, it's more than one thing, rolling a die and flipping a coin. So if you take a look at in your book, and then it's not even worth spending too much time over, because you really can figure it out as you go. If you take a look on page 131, decide whether the event is simple or not and determine the number of outcomes. For quality control, you randomly select a machine part from a batch that has been manufactured that day. Event A is selecting a specific defective part. Is it one thing I'm doing? I'm only doing one thing, right? I'm just selecting a part. So if you're selecting a part, then that's a simple event. It has only one outcome. Event number 2 says you roll a 6-sided die. Event B, they just labeled the event that they want you to do. Event B says roll at least a 4. So what could you roll? A 4, 5, or 6. So that's not a simple event. If I just said what's the probability of a 4, you're good. Roll me a 4. But if you roll at least a 4, that says you can get any of those. It's like a complex one or a compound one. It's not a simple event. So very, very basic. If you take a look at the try it ones, we'll hit those real fast. Okay. You ask for a student's age at his or her last birthday. If the student's age is between 18 and 23 inclusive, is that simple? One answer you're looking for, or more than one answer? More than one answer. So is it a simple event? No. That's how you classify it. Do I get more than one outcome? How many outcomes do I get for this? A bunch. How many would you narrow that down to? Yeah, but give me a number. Like, how many numbers are between 18 and 23 inclusive? What does inclusive mean? So I include 18, 19, 20, 21, 22, 23. I get 6 possible outcomes. A simple event says I can only get one outcome. So this guy, therefore, not a simple event. If the student's age I'm looking for is 20, how many outcomes do I want? 1. I want it to be 20. This is simple. That's how they classify these. So, not a major hit on this one. Okay. Your counting principle, I hit this yesterday with you. That tells you how many entries you're going to have in your table. And I kind of tried to see if I could bring back a little memory about the most popular ones are, I have 5 pairs of pants, 4 shirts, 3 kinds of shoes. How many different outfits can I make? And you multiply. So if I have another one that's popular is the ice cream one. I have 3 flavors of ice creams, 2 toppings, 3 syrups. So how many different kinds of sundaes can I make? 3 times 2 times 3. I multiply everything. And that's where your tree came from. That's where your tree comes from as well. So, and one event can occur m ways, and the second event can occur n ways. You just take those and you multiply them, m times n. You are purchasing a new car. The possible manufacturers, car size, and colors are listed. You have 3 manufacturers. You have 2 sizes you're looking at. You have 4 colors you're looking at. So how many different ways can you select a car for 1 manufacturer, 1 car size, 1 color? You just take these and you say 3 of these, 2 of these, 4 of these. You multiply. So this gives you 24 different ways. Sometimes you'll be amazed at how many different ways. When I was first, like way back when I was in school, I remember thinking, oh, I could easily figure out those without having to do a tree. It's more difficult because you got a lot going on. 24 different ways. You can pick a Ford, a compact, a white, a Ford, a compact, a red, a Ford, a compact, a black, a Ford, a compact, a green. You just went through that and you only used a Ford and a compact. So think of doing that pattern over and over again. You're going to get 24 possible ways to do these things, which is where your tree comes in. Your tree comes in handy that way. Okay. So your choices now include a Toyota and a tan car. So now they added Toyota, and now they added tan. Okay. So now, how many choices do you have? 45. How many choices for your first one? 4 times 2 times 5. You got 45? 40, right? 40. So, and kind of just eyeball this. 20 times 2, 40. Gave you more choices by just adding that in there, right? Gave you a lot more choices. You had 24 before. If I added one more card type and one more color, keeping it the same size, I'm in trouble. Let me just write that test, guys. All right, so let's see where we are now. When these ring out, kind of remember this somewhere along the line that you did probability, right? You should ring a little bit of the bell. Okay. All right. Now, these are great problems, and you probably remember one of these kind of problems. Using your fundamental counting principle, you need to find an access code for a car security system that consists of 4 digits. When you do this, start with 4 digits like this. How many digits are there? 10. 0 counts as a digit. Yes, he does. Do you want to talk to him? Okay, hold on. Hold on. Michael? Stay home, please. All right, so you have 4 digits. Each digit can go from any number from 0 to 9. So there's your 10. How many access codes are possible when each digit can only be used once and not repeated? Okay, there's 10 digits. So I have how many choices for my first one? 10. If I chose a 1, how many choices for my second one? 9. If I chose a 3, how many choices for my third one? 8. If I chose a 5, 7. And you take these and you multiply them. Okay. These cannot be repeated. Not repeated. What's the difference if they can be repeated? How many choices for my first one? 10. How many choices for my second one? 10, 10, 10. And you multiply these. 10,000 choices for my, down here, if I can repeat. Okay? If I can't repeat, then I start with 10, 9, 8, 7. I work my way down. And that answer was 5,040. So look at the difference between these. And this was 10,000. A big difference, right? A big difference between these. And able to repeat them. Now, here's another scenario. Each digit can be repeated, but the first digit cannot be a 0 or a 1. So again, start with you have 4 possible things. I can repeat, but the first digit cannot be a 0 or a 1. So out of this, I can't use a 0, I can't use a 1. So how many choices do I have for my first position? 8. I took 2 away. I can't use a 0 or a 1, right? How many do I have for my second one if I can repeat anything that I want? 10, then 10, and 10. Without laying these out, it's hard to visualize this. So I multiply these, I get 8, I get 1,000 times 8, I get 8,000 possible ways to do this. It's a lot of different ways. These are where your access codes come from. So if you have a 4-digit thing and you say, I can't remember, I'll just keep trying numbers, you can be there a very long time trying numbers. And the best part is you got to keep track of the ones you try. So you got to keep track so that you don't keep retrying those. So, and they don't usually like to use zeros or ones. Zeros especially, it used to be, you know, when you called your phone all the time, you called 0 for an operator. That was way back in the day. Now you dial 911, so a lot of times they'll get rid of the 9. You won't see an area code with 911 because it'll go to 911. So there are times that they say certain digits can't be used. So we kind of feel what's going on here. This is important that you get this. So you guys try this. Try this one first. I want to see you lay it out. So we're going to lay out 6 positions. Out of the 26 letters, each of these can be repeated. So what are these going to have on their lines? 26. 26 for everybody. And what are you going to do with these numbers? Multiply. Your counting principle says multiply them. That's a lot of license plate numbers. So you get something that looks like this. Is this right? Okay, that's good. I'm going to miss a number. Now sometimes your calculator puts these into scientific notation if you got a lot of zeros on them. So just watch for that E thing in this. Because if it says like 108 e to the 6, that means 108 times 10 to the 6. That means it moved this decimal, or it might say like 1.08. It moved the decimal 6 places to the right. This one had numbers all the way through, so it had to give you the numbers. This one, I start the same way, 6. But what's different here? Can't be repeated. So what do I start with? 26, then what? Did I write 6? Okay, and how many do you get from this? A lot, right? Not quite as many as those, probably almost half as many as those. Now, this is really annoying to have to write this out, isn't it? Do you guys remember using these probabilities? Things taken so many times at a time. Combinations. Things, you put a C in there. Maybe. So how many spaces do I have here? I have 6 spaces. These guys, well, this one you can't get around there, but this one you can over here. If I start at 26, I want to go down 6 spaces. This tells me I start at 26, then I go 25, then I go 24, then I go 23, and it multiplies it for you. If you're going to find this, you can find it on your calculator. You could go to math. What happened? Yeah. I'm just going to show you where to find it, though. You do have to type in the 26 first. So when you go here, underneath math, if you go to probability, this is where all your probability things are. Your NPR, your NCR, your factorial. Do you remember factorial? Factorial means you started a number, you go all the way down to the 1, to the 0, to the 1, actually, because you can't multiply by 0. You go, like if it says 7 factorial, it goes 7 times 6 times 5 times 4 times 3 times 2 times 1. All the way down. This one's only going to go 5 positions. So that's going to be a P. And just like Chris said, when you go to use this, notice the N comes first. You're going to have to put the N in. Then you're going to have to come here. Then you're going to have to put that and put the other part in. So it's a little bit quicker. So if I put the N, I have 26. And I want to go down 6 positions. I come here. It's all together. They're all in one. And I want to do 6 of these. And it actually multiplies it a lot nicer for you. That would be the easiest one. This one you don't have one for. You could do this one, 26 raised to the 6th power. And then you don't have to worry about multiplying them all out. But you're going to find your probabilities all grouped together under there. Okay? All right. So let's try this. We've got 6 letters. 6 letters, each of which can be repeated. So that tells me I can use them over again. Except the first letter cannot be A, B, C, or D. So out of 26 letters, and they cannot be in A, B, C, or D, how many do I have that I can use? 22. So what should my next one be? 26. These have no restrictions. 26, 26, 26, 26. You could do this like this, and then multiply 26 to the 5th power, so that you're not multiplying like crazy on your calculator. Okay. This only had a restriction on your first letter. Generally, like if you think about license plates, I don't think they ever use an O, the letter O, or the number O to start with your license plate. I don't think they use an I either as a valid entry, because an I looks like a 1. I'm pretty sure they don't. I know they don't use a 0. I'm pretty sure they don't use an I, unless of course you have a special license plate. So is this kind of making sense? Okay. What I thought I would do is give you guys a little bit of an assignment to do.